Hey guys, and welcome back. Let's go ahead and take a look at how to set up our horizontal pod autoscaler resource. So in the previous video, we set up the service controller. We set up a deployment controller that has a single pod replica, and we also spun up a client pod running the Ubuntu Linux container image, and we just interactively installed the Python-based HTTP IE utility. And we used that utility to confirm that we could connect over to this service controller on the cluster IP on port 80. And so we confirmed that traffic is correctly being routed from this service controller over to one of our pods that has our Nginx container running inside of it. Now, this might confuse you just a little bit, but pods can actually have more than one container, so that's why I kind of put more than one container inside of a pod. However, the pod that we spun up in our deployment controller only has a single container defined inside of it. Now, oftentimes you'll see that pods might have a secondary sidecar container for perhaps security purposes or forwarding logs from the main application container over to a different logging service or something like that. But in our case, we just have a single container per pod. So this is kind of what it looks like. We have pods and there's a single Nginx container running inside, just at the moment, a single pod. However, we are going to scale this pod up. But before we do that, let's just take a quick look at what would happen if we were to hammer this one pod from our client. So back over here on my Ubuntu client container, I'm going to go ahead and do an apt install Siege. And Siege is just a very high performance utility that allows us to hammer a web service. So if we run Siege, you can see it's got a bunch of different options here available. You can tell it how many times you want it to run the test, how much time you want it to run the test for, if there's any delay between requests, and things like that. But I'm just going to use it in the basic configuration where you basically just specify a URL with no options. So if we do Siege and then HTTP and just hit biz website svc, then this is going to just hammer that service as hard as it can. And in the meantime, while that's running over here in this window, I'm going to open up a new tab. And we're going to go ahead and just run kubectl top pod and just see what's happening in terms of resource utilization on that pod. So as you can see, we configured our pod to request 50 millishares of a CPU. However, under its current configuration, where it is being hammered by another pod, our Ubuntu client here, you can see that it's actually spiking up to hundreds of millishares of a CPU core. So basically, it's exceeding our expected request parameters for our pod controller. And so what we're going to do is configure a horizontal pod autoscaler to automatically scale up our deployment controller to increase the number of replicas that are available for the deployment controller. And so what that should ultimately do is, for multiple pods within the same deployment controller, it should actually decrease the overall load by spreading the load across multiple pods instead of just having a single pod take all of the load for that application. So it looks like just a single pod is kind of leveling out around 380 millishares. That's kind of where it's peaking out, being hammered by the Siege utility from our Ubuntu client pod. And that Ubuntu client pod is actually consuming a lot more resources than the actual server component is. So that's just kind of an interesting observation there. All right, so what we need to do in order to configure the HPA, or horizontal pod autoscaler, is head back over to this walkthrough documentation for the horizontal pod autoscaler resource, and then we'll find the documentation to create a horizontal pod autoscaler. And one option that you have if you want to create the resource imperatively is to call kubectl and then autoscale. And that will allow us to create a horizontal pod autoscaler resource. So if we run kubectl and then take a look at the different subcommands here, you can see under deployment commands we have rollout, scale, and autoscale. So we could manually scale by doing scale here, and that's equivalent to doing what we did in an earlier video where we edited the deployment controller and set a new number of replicas for that deployment controller. But in this case, we are going to use the auto-scaling feature instead. So let's take a look at the options available for that context. So we'll run kubectl autoscale, and then we'll do --help, and that'll print out the full help documentation here. All right, so if we take a look at the different options available here, you can see that one of the core options that we're going to have available to us is CPU %. So if we specify this parameter, this is going to give us kind of a target average percentage of load that we want to have on a particular pod in our service. So at the moment, we're exceeding our desired CPU utilization. And as you can see, this is going to be a percentage of the requested CPU. So because we know from our earlier testing that our Nginx pod here is actually using around 380 millishares of CPU at its peak, what I might actually do is edit my deployment controller to actually change our pods to request maybe like 150 instead for each of those pods, just so that we get a little bit more balance here, because 50 would actually result in us getting maybe 8 different pods created to go up to about 400 millishares of CPU. And maybe we don't want to spin up that many pods. So what I'm going to do for now is actually just edit that file for our deployment. So let me get back into my Git folder and then go to HPA. And let me do vim on deployment.yaml. And instead of doing 50 millishares, I'll change this to, let's try 125. All right, so I'll save that. And then we'll do a kubectl apply on that file, and that should change our deployment configuration. I think it's going to create a new replica set, so let's just do kubectl get all and see what's happening here. And it'll have to create a new pod with those new settings. And so sure enough, it did create a new replica set, so that's 8 seconds old. So this is our new replica set, and you can see it's actually in the process of spinning up a new pod and terminating the old pod from the old replica set. So that's a really nice thing about the deployment controller, is that it handles the replica set management for you. All right, so what we want to do is basically set up an auto-scaling rule on a deployment, and we're going to give it a deployment name that we want to create the autoscaler for, and then we can set a minimum and maximum number of pods as well as our target CPU percentage. And if we set our target CPU percentage low enough, we should actually see that our number of pods in our deployment actually gets increased. So let's go ahead and do this. Let's do a kubectl and then autoscale. And again, we're going to specify that it's on a deployment. Let me actually do the help again here really quick, just so we can kind of see what that looks like. So we're going to be doing kubectl autoscale. And then we're going to specify the type and name of the resource that we want to control, which is going to be a deployment. And our deployment is named Nginx website. So that's our deployment controller. And so you could either do this syntax where you put a space in between the resource type and the resource name. And you can also do the typical / there as well, where it's all one parameter. Either of those is valid in Kubernetes. And then we can specify our minimum number of pods. So we'll say minimum, let's say 1. And then we could say max and say I want a maximum of, let's say 2 for now. And then for our target CPU percent, we'll say how about 50%. And so basically out of the 125 millishares that we set for our pods, we're basically saying that we want our target CPU percentage to be 50% of that request limit that we plugged into our deployment configuration. So I'll hit enter, and that will create a new resource inside of this namespace. And the type is horizontal pod autoscaler, and that is part of the autoscaling special interest group in the Kubernetes ecosystem. And the resource that we're affecting here is Nginx website. And so it says autoscaled. So that's just confirming that the resource has been created and that the service should be autoscaling. Let's do a kubectl get all on the website namespace that we're working inside of here. And we should see that within a matter of seconds here, we have a brand new pod running. So this pod is only 13 seconds old. The first pod is several minutes old here. And so what's happened is that our deployment controller has had the replicas updated by the horizontal pod autoscaler. And the horizontal pod autoscaler has basically told the deployment controller, I need you to spin up an extra pod because, this pod right here is just suffering under so much load. He's at, hundreds % higher than he should be. And so we need you to spin up an extra pod in order to reduce the load on the pods altogether. So what's happened here is that it's actually updated our deployment controller to have 2 replicas instead. The deployment controller went over to the replica set and said, hey, replica set, I need you to spin up another pod. So the replica set then in turn went ahead and spun up a new pod. So we still have our Ubuntu client over here. Let me just minimize that really quick. We've got our Ubuntu client that's sitting over here, and he's still hammering away at the cluster IP for the service controller that we created. And when we spun up the extra pod there, the load is now being balanced across both pods. And how can we confirm that? Well, we can use the kubectl top pods command. And that's going to show us the metrics for each of the pods. And as you can see, we have 2 pods in our deployment, and each of those pods is now seeing a balanced portion of the load that's coming from the Ubuntu client pod. And so rather than having a single pod get hammered with, what was it, like 380 millishares of CPU utilization, we're now seeing the number reduced on one of the pods, and the second pod that got spun up is taking a big portion of that load. Now remember, in our horizontal pod scaler, we artificially capped it at, I think it was 2 pods. And so this deployment controller is never going to scale to more than 2 pods. And if we take a look at our HPA, let's do kubectl get HPA, and this is going to show us what our actual consumption is versus our target consumption. So right now, our average total consumption is 140% of what it should be, and our target is 50%. And so what this is telling us is that if we allowed this HPA to increase the number of pods in our deployment, it would, because 140% is way higher than our target of 50%. So what we can do is edit that HPA and allow it to increase more pods in our deployment controller. So we'll do that in the next video and just continue to play around with this resource. I hope this has been informative for you, and I'd like to thank you for viewing.